Bismillah ar-Rahman ar-Rahim. Dear students, this is our second classical synchronization problem or concurrency problem, what's called as a reader's writer's problem. This is all kind of problems where we have a shared resource, and there are reader processes which are trying to read from this, and there are some writer processes which are trying to write or update that shared variable or linked list or whatever it is. Okay, so readers will only observe, not modify data. Okay, and the writers are gonna change, update the data. So what we want to do is if multiple readers comes in and start reading this buffer or whatever it is, there is no problem. Okay, say for example I have written something there, 24, so this is the score of a match right now, and there are many reader processes which are trying to read it. There is no problem, whatever it is. So this is my favorite player, player 8 says score. Okay, and he's playing and updating it as well. And if there are reader processes which are trying to read from this, if one reader comes in, second reader comes in, and any many reader comes in, there is no problem whatsoever. But when the writer comes in, it is trying to update it. Say it's trying to write it now. Say maybe I change my pen. Let me change to the red. Say it's now he has no, hit a 6, so the score is 30. He started writing 3. The moment he started writing, if you allow the readers, they are reading 34. In fact, it is a 30. So we should not allow readers when you are writing. Okay, so this is a 30. Okay, so if there's a case that other writers are also there to update, say this is some variable, a shared variable which need to be updated by many writer processes, then you are writing on this side 30 and other process comes in and he started updating that. Say he has to make it a 40, so he's writing 4, so it's a kind of a mess. So when one writer writes, these also need to be reframed. So when a writer comes, the readers need to be reframed and the writers need to be reframed. Okay, and if the readers come, okay, then there should not be a writer. Is it or not? So if a reader is reading this file, the writer should not write. So in fact, we say out of this, the first reader comes in, he should block the writer. So that's why we may have a semaphore called WRT. So that is the semaphore for blocking, for locking this shared variable. Okay, so when the first reader comes in, he may do wait on this write, and that means initially write will be 1, then it will make it 0 by wait operation, and that means technically it's locking this. So all these writers will do wait on write, so they will found it 0, so they're gonna sleep. Okay, and when this reader comes in, it does the wait on write, but the next reader can come, he don't need to write. So for that we have a variable, maybe read count. Okay, we have a count variable, a read count. Initially it was 0. When the first reader comes in, we'll make it 1. So we'll say if the read count is equal to 1, you got to do this, you got to do wait on write, because next reader comes in, he should not be doing wait on write, because writers are already blocked. You don't need to block it, so they can access this shared variable many. Okay, but when you are done, you are decrementing the read count. So we will say at the end, when, because we have to release the lock as well, so we will say when the count will hit the 0, that means there is no reader at all, then you can actually do what? You can signal this write. That means you release the lock, the writer can come in. Now this, what I'm talking about is that I'm giving precedence to the readers, that readers, the first reader will block all the writers, or you may give the writer the precedence. Okay, so depending on that, we will have two solutions for the first reader's writer's problem and a second reader writer problem. In the first reader writer problem, reader is a boss, we give preference to the readers, and in the second reader writer, we give preference or precedence to the writers. Okay, let's try and see these algorithms, and very simple, let's work them out. So what we are saying is the reader process and the writer process on this side. Okay, now we have while true and repeat forever whatever you do. For this is the while loop which will run forever. And the first we do the mutex. The mutex lock is done on a read count. Okay, because when we are actually accessing this variable read count, initially the read count will be 0. Okay, here it is 0. And to lock this variable, because we want not the two readers come simultaneously, and there may be firstly read count is 0. If two processes come simultaneously, both of them increment to 1. So in fact it should be 2. We can so say this is read count and this is 0. If two processes come on simultaneously, they will increment it from 0 to 1. Okay, in fact there were two processes, so it should have been first process come in, make it 1, then second process come in, make it 2, right? So that's why we have to lock it first. So that's why we use a mutex for that, to lock the read count. Okay, and we are checking if this is the first reader, because I said if many readers come, no problem, but if it's the first reader reading this file, this may be a file as well or anything else, it should lock the writers. So writers should be locked. So first reader will apply this wait on write. Okay, so that's why we're saying if read count equals to 1, that means the first reader. Then we do the wait on write. That means on a write semaphore is the 1 in the beginning, that is lock is free. Now you can make it by using the wait on write. Will decrement, because wait says if write is greater than than 0, sorry, then decrement it. Write becomes write minus 1, else sleep. But this is 1 greater than 0, so we can decrement it, and this write will this time become 0. Okay, and after that what you do is you signal the mutex. Okay, that means you are releasing the lock so that other readers may come in. So you are saying that other readers, you can come, okay, grab a lock and increment your read count and go on. But writers, if any writer comes in, writer code is very simple, that it waits on write. If write is not free, definitely this time it is not free, it is 0. So what will it do? It will go into the sleep. Okay, if it is free, if there is no reader, this write will be 1, then it will make it 0. That means it locked it so that other readers may not come, because when the writer comes in, no readers, no writers allowed, right? So it will block it. This write semaphore will become 0. Okay, so write semaphore becomes 0. So any reader comes in now, because it will stuck here, right? And any writer comes in, it will stuck here. Okay, so this process only can then write a resource, and then it will signal the write. Okay, okay. Now here, if a reader comes in, it blocks the write. Okay, it locks it, so no writer can come in, but readers can come in because it is signaling the mutex. This mutex is becoming again 1. Okay, now other reader can come in. He will read count will become plus. If it is 1, it will become 2 and 3 and 4. How many readers will come in according to that? And we say if read count equal to 1, this will not happen, because this was done by the first reader. So next time read count may be 2, 3, 4 and so on. So this is not necessary. So you release the lock on mutex so that other readers may come in, and you read the file. So all readers are reading simultaneously. So we may have 3 readers, 4 readers, 5 readers, many readers. They are coming in and they are reading the file. And the first reader who came, he has blocked the write. Okay, if if write was free, you can block it. If it was not, you also will go to sleep. Okay, now say for example there is no writer and readers have come, 3 readers have come together, they are reading the file, no problem. And after that, say particular reader is finished, he should first lock the read count by wait on mutex. Okay, and decrement the read count. Now we check if that read count becomes 0, that means this is the last reader. Right now there are 3, so read count will be, our read count value is here 3. So when this is decremented, so it becomes 2. And if another reader also finishes, it becomes 1. When the last reader comes in, he decrements it, it will hit 0. So that means the last reader's job is to release the lock on write. So that's what we're saying. If read count hits 0, you got to release the lock by signaling, by calling signal on the write. So what signal does is it will increment the write from 0 to 1. It will become 1 again. So when it is 1, it is free, so any writer can come in now. Okay, now here you signal the mutex because you have wait on mutex. You have to signal the mutex so the other readers may come in as well. Now first reader competes with the writers and last reader signals writers. So but if readers start coming and coming and coming, writers will be starved. Simple as it is, isn't it? Because so there will be no update at all. So if the readers are coming in and because we are waiting for the last reader who will signal the write. Maybe there is readers who are coming and coming, so writers can easily starve. That's why we have a second solution, okay, which will give a little preference to the writers. Okay, this is our second solution where we've got the writers precedence. Okay, so here we have added this semaphore RD, which just happens to be counting semaphore. Okay, so before we read, we do wait on RD, and if you see in the beginning, read count is 0, write count is 0. We got the write count also now because we are saying that if first writer comes in, he will block the readers. Okay, and then there may be other writers who comes in, but the readers will be blocked only. Okay, and writer will go if the first writer finishes, second writer may come. So what I was saying is if the writer comes in, okay, he may write it, but he will block the readers. He blocks the readers. Okay, in the first solution we are saying, okay, when it is done, now reader may come and block it, but what we are saying, we are not releasing the lock, so no more reader starts reading. So readers may come up and start waiting here, going on a sleep queue, and if other writer comes in, if this finishes, this can go. If this finishes, this can go. Okay, so we may have two kind of locks here. One lock is for the when this writer is actually writing to this, so this writer may not interfere, so we need a lock for that. Okay, and we need also a lock for readers. That is what is reader lock. So we got a reader lock, we got a write lock. Okay, we got a write lock. So when first writer comes in, he may do the write lock, okay, and as well as the read lock. Now when this writer is done with this, he will release the write lock but not the read lock. Okay, it is the job of the last writer to release. So what I'm saying is, first writer comes in, he locks the read lock as well as write lock. When he finishes, he will release the write lock and not read lock. The second writer comes in, he locks the write lock, but and then when it's done, he release the write lock. The third writer, who is the last one, comes in. Okay, he will he will lock it first with the write and then release it. Okay, and his job is also, if there is no writer left, then he should also release the read lock so that other readers may come in. So this will give precedence to the writers as well, right? So that's why we are doing first, we are doing wait on RD, we are doing wait on the read lock. Okay, if the read lock is 0, so we can't actually access further, right? The readers can't access. So if you see our reader on the first is 1, that is it's on, and write is on as well. Okay, then say for example some reader comes in. What he does is, he will do first wait on mutex. We got a couple of mutexes now because we got a 2 read count and write count. Read count is locked by mutex 1 and write count is locked by mutex 2. So when the writer comes in, he will wait on a mutex 2 so that he will see, any writer will see with the write, some other writer is not this time writing. So if some other writer is writing, he may have done wait on mutex, so mutex will have 0. So if this writer will be blocked. But if there is no writer, this mutex will be 1. In the beginning, mutexes both are 1, so they are free, or we can say. Then you can do what? Because they are the binary semaphores. These mutex 1 and mutex 2s, they are binary semaphores. Okay, they can take 0 or 1 value only. Okay. Now, if in the beginning mutex 2 is free, now what you will do? You will wait on mutex 2, make it 0. That means you have blocked it, so no writer can come up and actually increment the write count. Okay, now this writer has come up, he will increment the write count. So write count has gone to 1. Initially write count was 0, so it has gone to 1. Okay, if write count is 1, yeah, it is the first writer, then you will block, actually you will lock the RD, that is read lock. Now RD will become, because RD in the beginning is 1, it's becoming 0. Okay, now if the reader comes now, because he is doing the wait on RD, so read RD is 0, so he can't access it, right? He can't access it, so he has to wait. He's sleeping here, so any reader now comes in, they have to sleep. All readers, say maybe 2 readers, 3 readers come in, they are all sleeping here. Say for example R1, R2, R3, they're all sleeping, waiting for RD to get released, isn't it? Now here this writer now signals mutex 2 because he has done with the write count, he has incremented the counter, and so he should signal it. Okay, so that other writers may come in, no problem, they can come, increment the write count, but this guy will also now wait on write. Okay, now wait on write, so write was initially 1, so it becomes 0. Okay, now he can access the critical section. Maybe other writer comes in. When other writer comes in, they are free to actually hear, because this mutex 2 is free now, because we have signaled it. Okay, mutex 2, that means it's become 1 again, so the other writers may come and increment the write count. Say others, say here they will lock it. Okay, lock the mutex 2 so that they can access the write count and increment it to the 2, and but it's not the first one. Write count has become 2, so this code will not happen. This will happen only the first writer, and they will release the lock of mutex, and they will be stuck here because this writer is now writing, so they are stuck here because the WRT is, the write lock is 0, so no other writer can actually access it. Okay, so they are waiting. So maybe 3 writers have come up, so write count has become 3. Okay, and now first writer is finished, he will signal write. Okay, he will signal write, because now write here has become say it was 0 for the first case because it was 1, isn't it? Because write was 1. When the first guy comes in, he will do wait on write, so he will make it 0. Okay, now other guys are actually sleeping because they do write, because write is not greater than 1, so they are not gonna decrement it, they're gonna sleep. Is it? Okay, so when you actually signal write, write becomes not 1, right? Because we say in signal, if somebody is sleeping on this semaphore, you're gonna wake them up. So this signal will wake another writer. Okay, and then you actually, this writer will do what? This writer will decrement its write count. That's why it's locking the mutex 2 and decrementing it. And in the meantime, other writer may come and access the this start writing. Okay, then that writer will also decrement its count until the last writer will come in, and it will decrement count. And this if will be only true for the last writer. When the write count has hit it 0, there is no writer left. When there is no writer left, you can signal the RD. That means you can signal the read count. Okay, read semaphore. Now you signal the read semaphore. That means it's becoming 1 again. So you increment it, and actually you do what? So these guys who are sleeping on the RD may wake up. So now this signal has a job to actually wake one of the reading processes. They may come up and they will lock the read count and increment it, and we say if read count is equal to 1, then you're gonna wait on write. Is it? So if the read count is now 1, they can wait on write. So write is blocked. Now they signal mutex. Now they signal RD. Now RD is signaled back. So that means it is again free. So in the meantime, if some writer comes in, he will block this RD here. Okay, so that means no readers may further come up and writers may go on and on. Okay, so in this case we are actually giving some precedence to the writers. Now the reader may read its stuff and then does read count -1, and if in the meantime there was no writer and the readers have come up, say 2-3 readers have come up, and at the end it will see if there is no reader count, it will signal the write. So That is the what we did in the first solution as well. Okay, then we release the lock on the read count. Okay, so we had here the mutex one, which was trying to lock the read count variable, and mutex 2 on the write count variable. Then we have read lock and a write lock. The read lock will block the readers and write lock will block the writers. Okay, um, does make sense? And here, for example, a writer is doing the write lock, so the other writers may not come up, and this writer is also blocking the readers here. Okay, so that readers may not come. So writer is blocking both readers as well as writers, and the reader here is blocking the writer. If the reader is coming, writer should not come. Okay, okay, does make sense? um, so this is the overall scenario of the readers writers problem. um, Now in the next video we may see the dining philosophers problem.